Okay, what we're going to do here is just try to start using the inverse trig functions to find one solution. We're going to try to do this the way we should, though. We're going to make sure there's a solution first, estimate it, use the calculator, and make sure our estimate shows up, coincides roughly with the calculator. Meanwhile, how do we start? I know that on the unit circle, tangent is slope. So I'm just going to come over here. I'm going to try to draw a unit circle. And I know I'm supposed to draw a line through the origin whose slope is -2. I know if I draw a line through that, the slope is -1, so I'm just going to try to make it roughly twice as big like that. And so what's going to happen is we want the distances to here and to here. Now inverse trig will only give us one. It always gives us the closer one, so I'm thinking it's going to go about like this. Now how far is that? Remember, going all the way back this way is -1.6. There's -1.8. I'm thinking about -1.2. So at the moment, I'm thinking when I use the calculator button, I should get an answer like something like -1.2. Meanwhile, what we want to be able to do here is take the inverse tangent of both sides. So we're not going to write it all out this way every time, but it can't hurt once or twice. I'm going to say the inverse tangent of t is going to be equal to the inverse tangent of -2. Now what in the world is inverse tangent of t? Well, remember that tangent does horrible things to t, but inverse tangent is designed to completely undo it. So what you should be left with over here is t. So I'm going to go to my calculator, and the calculator says that inverse tangent is equal to -1.107. And I'm not going to round anything because I don't know what it's going to be used for. 148,718. We usually underline the last digit to say it's rounded that far. Now we guessed about -1.2, which is not bad considering how quickly you got it. The actual answer is about -1.1. Remember, that's only one solution. There are many others. We'll talk about that in the next thing. All right. That was solving an inverse tangent equation. The next equation I want to solve is an inverse cosine equation. And I'll say solve inverse cosine of t equals, and I picked -0.5 as an example. How does this work? I know I'm supposed to draw the unit circle. No. We're solving a trig equation. There we go. I know I'm supposed to draw a unit circle. I'm going to be in trouble over here. We'll draw it way over here. Give my space to write some answers. There we go. Now what happens? Cosine is x. So I'm just going to write x. Remember, the reason we write that is so now we can draw the line x equals -0.5, which is way over here like this. Yes, like this. And so we get this point. I guess I've been putting those points in red, so let's hit that point. So this point right here has an x coordinate of -0.5. This point right here has an x coordinate of -0.5. And what happens is inverse cosine will give us one of those answers. There are going to be many. Inverse cosine only gives us one. Which one? The closest. Well, they're both the same closest, so it also has the additional condition that it has to be positive. So I want this distance roughly. Now remember that this getting to here is about 1.6. Getting to out here is about 3.2. Halfway is about 2.4. Let's see, what do I think? 2.0 or 2.1. I'm going to say about 2.1. So down here, this is going to be my check. I'm going to say 2.1. Meanwhile, I'm going to start with this equation. I'm going to take the inverse cosine of both sides. On the left-hand side, I'm going to get t. On the right-hand side, I'm going to get the inverse cosine of -0.5. Now I am going to go to my calculator and type in inverse cosine of -0.5, but remember, even my calculator value is only an estimate. These numbers go on and they're very strange to look at. My calculator's estimate for this distance is 2.094. And again, I'm including all the decimal places because I don't know what it's going to be used for. 395, 102, like that. And you can see that 2.1 was pretty close. So it's not so bad. So solving a trig equation with inverse cosine, It gets us a good answer, and then we can check our answer. Let's do an inverse sine one. Very similar to the inverse cosine one. Probably a tad easier. This one I actually used the same value. I said I want to solve an equation, a trig equation, so it's sine t equals 0.5, like that. I'm going to go to the unit circle to see what that means. I know that sine t is the y value on the unit circle, so I write down y equals. Now what did I do that for? Because now I can draw the line y equals 0.5, which goes exactly halfway through here, like that. And I can see I need to get to this distance. I need to go to distance to get to this point or this point. We've been making those in red. No reason for red, but I've been doing it. So hey, there we go. So this is red. This is red. Now, which distance will inverse sine give me? It's always the closest one. So it's about that distance, just like that. Now, what do we have here? I know to get to the top is about 1.6. To get halfway is about 0.8. Half of that would be about 0.4. This looks like 0.5-ish, even though that's different than that. So let's make it 0.6 just to say it's a little bit different. We'll say about 0.6. I think 0.5-ish is better, but there we go. Now, that's our estimate. We now use inverse trig to get the answer. I take the inverse sine of both sides. So I'm going to get the t equals the inverse sine of 0.5. Remember, inverse sine of 0.5 is the exact distance. When I go to my calculator, it's going to give me an estimate that's pretty good. Calculator says negative 0.523 598 7756. Now, why include all those decimal places, by the way? Lots of things only use 3 decimal places. Lots of things use many, 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 many more, and you always want to just give the decimal places that the context asked for. So I'm not going to round anything until I know what the context is. Meanwhile, I thought the answer was 0.6. I think my answer of 0.5-ish was better, but 0.6 is what I stuck with. The actual distance to this many decimal places, remember, is that according to my calculator. So that's how you use inverse trig functions to solve and find one solution to a trig equation. Remember, there are many more.